In this video, let's discuss independent events. Say we have two events E1 and E2, and these two events will be independent if E2 is not affected by the result of E1 and vice versa. That is, E1 also is not affected by the result of E2. Now, if these two events are independent, then if you need to find the probability of E1 and E2 occurring, that would be equal to the probability of E1 occurring into the probability of E2 occurring. Let's take an example. Say you have two people who are trying to shoot birds. Now, the probability that the person A shoots a duck is given as 0.2, and the probability that person B shoots a duck is given as 0.7. Now, the probability that A and B will shoot a duck will be 0.2 into 0.7, because these two events are independent. That is, it does not matter whether B succeeds or not, the probability of A shooting is still 0.2. Similarly, whether A succeeds or not, the probability of B will still be 0.7. Alright, now say that these two events E1 and E2 are not independent. If they are not independent and we need to find the probability of E1 and E2 occurring, that would be equal to the probability of E1 multiplied with the probability of E2 occurring once E1 occurred. Now let's see some examples to understand this in a better manner in the following videos. Let's do these two questions. A box contains 4 red balls and 3 blue balls. One ball is drawn from the box and then replaced. A second ball is drawn. What is the probability that the first ball is red and the second one is blue? Over here it's mentioned that after we draw the first ball, it is replaced. Therefore, the two events are independent over here. What are the two events? The first event is drawing the first ball and the second event is drawing the second ball. And these two events are independent because we replace the ball after doing the first draw. Let's find out what is the probability to get a red ball in the first go. That would be favorable cases, which is 4, divided by total cases, which is 4 plus 3, which is equal to 7. What about drawing a blue ball in the second attempt? That would be favorable cases, which is 3, divided by 4 plus 3, which is the total cases. And over here you have 7 because we have replaced the ball, right? So whether the first ball was blue or red, it does not matter to affect this probability over here. Therefore, the probability to get the first ball as red and the second one as blue is equal to 4 by 7 into 3 by 7, which is equal to 12 by 49. And you can note that we have just multiplied these two over here because they are independent events. Alright, let's go to the second question. It's all the same except that after drawing the first ball, it is not replaced. The second ball is drawn and we need to find the probability to get the first one as red and the second one as blue. Alright, over here the two events are not independent, right? The first event is drawing the first ball, the second one is drawing the second ball. Now let's find out the probability to get a red ball. That would be 4 by 7 because we have 4 red balls and the total number of balls is 7, right? Now what is the probability to get a blue ball given that initially you have got a red ball? That would be 3 by 6 because you have 3 balls but you are only left with 3 red balls and you have 3 balls. So 3 plus 3 is equal to 6 over here. You can note the difference. Over here the probability was 3 by 7. Over here it is 3 by 6. Now the probability to get a red ball and a blue ball is equal to 4 by 7 into 3 by 6. And over here you can note that we have taken the probability to get a red ball multiplied with the probability to get a blue ball given that already a red ball has been drawn out in the first event. And this is equal to 12 by 42.